The James Webb Space Telescope just gave scientists a big surprise with its latest pictures. There's a galaxy out there that's been around for billions of years. It's a space-time storyteller, witnessing stars being born and saying goodbye. But the interesting thing is that this old galaxy has secrets we've never even dreamed of. So, what kind of stories could it tell us about the universe? What has it been through all this time? Get ready for a journey into space with the James Webb Telescope, where we'll explore the mysteries of this ancient galaxy. A mysterious intruder is planning to attack Stephan's quintet, and probably a big space clash is on the way. We know that there is a group of 5 galaxies, each with its own unique identity. NGC 7317, NGC 7318A, NGC 7318B, NGC 7319, and NGC 7320, located approximately 270 million light-years away in the constellation Pegasus. This galaxy group is known as Stephan's quintet. Now, some astonishing findings were presented at the 241st meeting of the American Astronomical Society. Scientists have utilized the powerful tools of the Atacama Large Millimeter Submillimeter Array and the James Webb Space Telescope to peer into the heart of Stephan's quintet. What they discovered is nothing short of mind-boggling, a symphony of shockwaves, turbulence, and the birth of new galaxies. But here comes an intruder galaxy violently colliding with the galaxies of Stephan's quintet. This intruder, named NGC 7318b, crashes into the group at a staggering speed of around 800 kilometers per second. To put this into perspective, a journey from Earth to the Moon at this speed would take just 8 minutes. The collision triggers a colossal shockwave, akin to a sonic boom, several times the size of our own Milky Way. Now, here's where it gets fascinating. This violent collision is not causing a burst of star formation within the galaxies themselves, as one might expect. Instead, the action unfolds in the intergalactic medium, where there is little to no star formation to obscure our view. It's like having a clear window into the event. It encounters an old gas streamer, likely formed from a previous interaction between 2 other galaxies in the group. This collision sparks a series of events that have left astronomers astounded. The shockwave creates a highly turbulent cooling layer, leading to the recycling of warm and cold molecular hydrogen gas. Why is this important? Because molecular hydrogen is the raw material that may eventually give birth to stars. Understanding its fate unravels the secrets of galaxy evolution. Let's zoom in on the groundbreaking observations made possible by ALMA's Band 6 receiver. Developed by the U.S. National Science Foundation's National Radio Astronomy Observatory, this instrument allowed scientists to delve into 3 key regions with unprecedented detail. For the first time, a clear picture emerged of how hydrogen gas is moving and shaping itself in response to the cosmic turmoil. In the heart of the main shockwave, known as Field 6, a big cloud of cold molecules is disintegrating and stretching out into a long tail of warm molecular hydrogen. The intriguing part is that the gas doesn't survive the shock. It undergoes cycles of warming and cooling. The length of the tail exceeds the time it takes for the clouds to be destroyed, indicating a remarkable process of intergalactic recycling. But that's not the only surprise. In Field 5, scientists observed 2 cold gas clouds connected by a stream of warm molecular hydrogen gas. One of the clouds, resembling a high-speed bullet of cold hydrogen, punched through a large, thread-like filament of spread-out gas, creating a ring in the structure. The collision energy feeds the warm envelope of gas around the region, although the detailed implications of this phenomenon are yet to be unraveled. Now, let's venture into Field 4, the most normal region among the observed areas. Here, scientists found a steadier and less turbulent environment, allowing hydrogen gas to collapse into a disk of stars. What's truly captivating is the belief that a small dwarf galaxy is in the process of formation. The shockwave in this region has destabilized pre-existing large clouds of dense gas, leading to the formation of new stars, an expected outcome in the turbulent dance of galaxies. Back in 2010, Observations with NASA's Spitzer Space Telescope hinted at large clouds of warm molecular hydrogen mixed in with superhot gas. However, these clouds should have been obliterated by the massive shock wave sweeping through the group, raising the question of how they survived. To unlock this mystery, scientists needed more technological firepower. ALMA's capabilities, combined with the James Webb Space Telescope's imaging prowess, provided a more comprehensive understanding of the interplay between cold, warm, molecular, and ionized hydrogen gases in the wake of the giant shockwave. Yet, as we bask in the beauty of these revelations, we must acknowledge the gaps in our understanding. Spectroscopic data is the key to unraveling the remaining mysteries. We need to know the motions of the gas, the speed of the warm gas, its temperature, and how it responds to the shock waves. Essentially, we've heard one side of the story, and it's time to discover the other. But how do such violent cosmic events shape the destiny of galaxies? What role does turbulence play in the grand cosmic ballet? And what can the intergalactic medium teach us about the fundamental processes governing the universe? The National Radio Astronomy Observatory and the Atacama Large Millimeter-Submillimeter Array have opened a window into the cosmos, revealing a cosmic recycling plant, the disintegration of giant molecular clouds, and the birth of new galaxies, all triggered by the shock waves of celestial collisions. These findings not only deepen our understanding of Stephan's quintet, but also raise new questions about the cosmos that surrounds us. However, recently, the James Webb Space Telescope provided us with a captivating glimpse into this cosmic birthing process through a mesmerizing image of an object named HH 212. I can't help but wonder, what secrets does this distant corner of the universe hold? How does the birth of stars like our Sun shape the cosmos? HH 212, nestled in the Orion constellation, offers a snapshot of a star in its infancy, a mere 50,000 years old. The image captured by Webb unveils a stunning display of pinky red jets shooting out in opposite directions. These jets reveal the invisible drama unfolding within a dense, spinning disk of gas and dust. But why can't we see the protostar itself? What cosmic forces are at play in the creation of these radiant jets? To comprehend the dynamics at play, we turn to the insights of Professor Mark McCallren, a senior scientific advisor at the European Space Agency. He explains that the outflows of gas, depicted in the image as pinky red, are the star's way of regulating its birth. But how does this work exactly? Professor McCallren unravels the mystery, detailing that as the central ball of gas contracts and rotates, the challenge lies in preventing it from spinning too fast and flying apart. The solution? Jets and outflows. These bipolar structures, propelled by magnetic fields, expel material through the poles, creating the mesmerizing jets we see. I'm struck by the significance of the pinky red color in the image. It signifies the presence of molecular hydrogen, molecules with two hydrogen atoms bonded together. The shock waves coursing through the outflows energize them, making them glow brightly at the infrared wavelength of 2.12 microns. It's fascinating to think that the colors in this cosmic masterpiece are not just for show but hold valuable clues about the elements involved in the star's formation. The image of HH 212 unveils the complexity of the star's surroundings. The dense, infalling disk of gas and dust obscures the protostar, adding an air of mystery to the cosmic tableau. However, when we look closely at the left and right jets in the annotated picture, we can trace the knots of brightness and count the bow shocks. These are the areas where faster material collides with slower material just ahead of it. The symmetrical structures captivate the eye, except for a messy bow shock on the right. But what causes these asymmetries, and what stories do they tell about the star's formation? Astronomers have been observing HH 212 for 3 decades, documenting its evolution through periodic images. Webb's new view, 10 times sharper than its predecessors, opens a window into the complex processes driving star formation. Repeat observations even enable the calculation of the speed at which these elements are moving, astonishingly, at speeds exceeding 100 kilometers per second. While I playfully thought that HH stands for molecular hydrogen, it actually pays homage to the astronomers George Herbig and Guillermo Haro. These trailblazers conducted pioneering work on objects like the HH-212 in the 1940s and 1950s. It's surprising to think about how their legacy lives on through the capabilities of Webb. The telescope not only captures incredibly sharp images, but also expands the spectrum of colors it can detect. As Professor McCaughrean highlights, the main wavelength for observing objects like HH-212 is 2.12 microns, significantly longer than the mid-visible range. Webb's ability to observe at various wavelengths, previously inaccessible from ground telescopes, has provided a vivid color image of HH-212. This newfound capability allows scientists to gain deeper insights into the processes at play. The transformative impact of Webb extends beyond HH-212 to its younger cousin, HH-211, located in the Perseus constellation. Even younger, measured in mere thousands of years, HH-211 offers a captivating parallel to the early stages of our Sun. Reflecting on this, I am surprised at the cyclical nature of cosmic evolution. How do these objects in the Perseus constellation compare to HH-212, and what unique lessons do they hold about the formation of stars? Recent breakthroughs in astronomy have allowed scientists to catch a glimpse of shock waves rippling through the cosmos for the first time. Imagine our universe as a giant Swiss cheese, where galaxies are not evenly spread out, but rather clumped together in massive clusters connected by delicate filaments of gas and dark matter. These filaments make up the cosmic web, and they are the highways along which galaxies travel, pulled by the gravitational forces that govern the cosmos. The spaces between these structures are not empty voids, but intriguingly interconnected regions. Now, here's the exciting part. Scientists have always suspected that when galaxy clusters merge and filaments collide, shock waves are generated, setting off a chain reaction of cosmic proportions. The shock waves, previously only predicted by simulations, have finally been observed by astronomers. The challenge for astronomers has been to detect these shock waves, especially in the filaments, which are much harder to spot than galaxies. It's like trying to find a needle in a haystack, or in this case, trying to spot shock waves in the vastness of the cosmic web. But a team of researchers, led by radio astronomer Tessa Wernström, found an ingenious way to overcome this challenge. Instead of searching for individual shock waves, they combined over 600,000 pairs of galaxy clusters that were connected by filaments, creating a stacked image that amplified the weak signals emitted by the shock waves. Isn't it fascinating to think about the technology and innovation that allow us to see beyond what our eyes can perceive? Imagine the excitement of the researchers as they dug below the noise and unveiled the hidden signals. The resulting image showed a faint, highly polarized radio glow from the filaments. Now, you might wonder, what does it mean for the radio waves to be highly polarized? Well, in the cosmos, highly polarized light is quite unusual, but it is exactly what scientists expected from shock waves. This alignment of radio waves provides strong evidence for the presence of shock waves in the cosmic web. It's like having a cosmic compass that points us towards these invisible but powerful phenomena. Let's delve a bit deeper into the significance of this discovery. The polarized radio emissions not only confirmed the existence of shock waves, but also offered a rare opportunity to study the magnetic fields that envelop the cosmic web. These shock waves are like messengers that not only reveal their presence, but also carry information about the magnetic fields that shape the filaments of the cosmos. Astrophysicist Marcus Bruggen emphasizes that these shocks play a crucial role in showcasing the existence of large-scale magnetic fields surrounding the filaments. Radio astronomer Tessa Wernström expresses this uncertainty, highlighting that magnetism is a fundamental force of nature. Yet our understanding of its role in shaping the cosmic web is far from complete. Isn't it intriguing to think about the fundamental forces that govern the universe? Forces that are integral to the very fabric of space, yet remain enigmatic in their origin and significance. The discovery of shock waves in the filaments of the cosmic web not only confirms theoretical predictions, but also invites us to ponder the broader implications. How do these shockwaves influence the evolution of the cosmic web over time? What role do the magnetic fields play in shaping the cosmic structures we observe? And most intriguingly, what cosmic secrets do these shockwaves carry within their subtle radio signals? One exciting aspect of this discovery is the indirect peek it offers into the magnetic fields that envelop the cosmic web. It's akin to solving a puzzle where each piece reveals a bit more of the complex picture. Let's also acknowledge the incredible strides made by astronomers and scientists in unveiling its secrets. The combination of advanced technology, meticulous observations, and innovative data analysis has allowed us to pierce through the cosmic veil and catch a glimpse of the invisible forces at play. Scientists, despite their groundbreaking discovery of shockwaves, still find themselves on the brink of understanding these fundamental questions. What if, in the coming years, we unlock more secrets hidden within the cosmic web? What if we gained a deeper understanding of the cosmic forces that have shaped the universe since its inception? The discovery of shockwaves in the filaments of the cosmic web opens a new chapter in our exploration of the universe. It's a sign of human curiosity, innovation, and the relentless pursuit of knowledge. The cosmic web, once a mysterious backdrop to the dance of galaxies, now reveals itself as a dynamic and interconnected tapestry, shaped by the invisible forces of shockwaves and magnetic fields. Now, look closely. What do you think? It seems like a blurry, pixelated red and green splotch dissipating into space. But this unimpressive visual is the spotlighted galaxy Aztec 71, captured by the powerful James Webb Space Telescope. It's not some average, easily identifiable galaxy with a distinct name and mesmerizing features. This cosmic resident is just a string of numbers and letters, residing at a distance so immense that it eludes the watchful eyes of many telescopes. However, thanks to the James Webb Space Telescope, we are granted a glimpse into Aztec 71, as it existed a mind-boggling 900 million years after the Big Bang. The image we have of Aztec 71 is far from the dazzling portrayals of galaxies and galaxy clusters that we often encounter. Instead, it appears as a hazy speck of light. But this seemingly unimpressive view holds profound significance for our understanding of the early universe. Jed McKinney, a study author from the University of Texas at Austin, expressed his excitement about this discovery, stating, "The fact that even something that extreme is barely visible in the most sensitive imaging from our newest telescope is so exciting to me. It raises the possibility that there might be an entire population of galaxies that has been hiding from our gaze. The early universe, as portrayed by Aztec 71, could have been much dustier than we previously imagined. This revelation has the potential to shed more light on the evolution of the universe since the explosive birth of the cosmos, approximately 13.8 billion years ago. The faint, enigmatic glow of Aztec 71 is a sign of the hidden complexities that astronomers are just beginning to unravel. But how did Aztec 71 come into the spotlight? It was initially detected as an incomprehensible blob of light by the James Clerk Maxwell Telescope in Hawaii. Subsequently, the ALMA radio telescope in Chile caught a glimpse of this cosmic enigma. However, it seemed to vanish when observed by the Hubble Space Telescope, leaving researchers confused. McKinney exclaims, "This thing is a real monster." Despite its unassuming appearance, Aztec 71 is a celestial powerhouse, forming hundreds of new stars every year. It's a reminder that appearances can indeed be deceiving in the vast expanse of the universe. As part of an international effort to map the earliest structures of the universe, McKinney and his colleagues set out on a mission to locate Aztec 71 using data collected by the James Webb Space Telescope. This revolutionary observatory boasts an unprecedented infrared eye, capable of peering through the thick clouds of dust prevalent in the early universe. Before Webb entered the scene, galaxies like Aztec 71 were nearly impossible to detect. The light emitted by nascent stars within these dust-shrouded galaxies was absorbed at optical wavelengths by the dust itself. However, this absorbed light was then re-emitted at faint, longer wavelengths that Webb could effectively capture. This groundbreaking capability unveiled a group of galaxies that had previously eluded the Hubble Space Telescope, aptly named Hubble Dark Galaxies. The implications of this revelation are profound. McKinney highlights, that means our understanding of the history of galaxy evolution is biased because we're only seeing the unobscured, less dusty galaxies. But what's next on the horizon for McKinney and his team? Their plans involve uncovering more faint, hidden galaxies using the wealth of data provided by the James Webb Space Telescope. This remarkable instrument not only allows us to stare back into the farthest reaches of the universe, but also possesses the unique ability to pierce the thickest of dusty veils. The James Webb Space Telescope has opened a new chapter in our exploration of the universe, challenging preconceptions and beckoning us to peer into the hidden corners of space. What other celestial secrets await our discovery, concealed behind the cosmic veils of dust and time? It's a thrilling journey of cosmic exploration that keeps us yearning for more answers to the fundamental questions about our existence in this vast, mysterious universe. Did you catch all those mind-blowing discoveries? The universe is like a gigantic puzzle, and we're uncovering its secrets piece by piece. But guess what? The excitement doesn't stop here. Join us on our journey and never miss out on the next big cosmic revelation. Hit the subscribe button and turn on notifications. A big thanks for joining us on this space adventure. Until next time, keep looking up, stay curious, and keep dreaming among the stars.